Good afternoon, guys. I hope you guys are doing well. Okay. This is the guy tweaking behind all those videos that I've recorded. So, okay, guys. If you check under my YouTube channel, you will see that there are videos for STTN121, STTN121. It's test one, part one. So now under this one, it will be part two. I'm gonna do this one will be STTN121 part two, and also soon I will create videos for STTN124. So please like and subscribe to my YouTube channel so that you can be able to see more of my videos. And another thing, the module statistics is easy. The aim is to make sure that you guys understand statistics modules, not for you guys to when you see like, no, this module is difficult. The aim is to make sure that I make sure that you guys understand this module. So I'm going to share my screen. I'm gonna share my screen, and this is what I'm gonna. Okay, do this one. Okay, all right. Okay, it's fine. All right, now let's see. Okay, I remember on the previous video that I recorded, I remember I did 8.1 to 8.9. I remember I explained 8.1 till 8.9. So now on this one, I think I'm on 8.10 now. Yeah, I'm on 8.10. Okay. Let's see. I remember, yeah, I'm on 8.10. All right. Okay, guys. Okay, this is what I'm gonna take this one, put it here. Here. Okay. Okay, guys. Now, under 8.10, if you check under 8.10, we are still dealing with the random variables. And remember, I told you that it's very important for you to understand the definition of a random variable. It's very important to understand this random variable definition. So this formula, you know that you guys, when you were doing STTN triple one, when you guys were doing STTN triple one, you used this formula to calculate the relative frequency. Use this formula to calculate the relative frequency. Now, under the random variables, okay, let's check and see the continuous random variables. Okay, let's see. Um, where is it? This is very important. The properties of the continuous random variable. It is very important, guys, to understand that when you are dealing with the continuous random variables, it's very important for you to know this definition of the probability density function. Okay, I want to do it like this. Okay, it's fine. Let me delete this part. It's very important for you to know this definition. Is that okay? It's fine. Let me just do it like this. This definition of a probability density function, which is fx. So meaning probability density function, which is fx, it describes the distributions of the probability for a continuous random variable, which is this one here. So we have the properties of fx, which fx stands for the probability density function. So now I believe that you know that fx stands for what? The probability density function. We will use it under the random variables, continuous random variables. Okay, now we have the one property is that the total area under the probability density function is equal to 1. This one, meaning when you add all your probabilities density functions, when you add all of them, you must get 1. You will see when we do, because I think I have few question papers here, but the problem, the only question papers that I've managed to download, it's question paper plus including memorandum. I don't have a question paper aside, and then it's question paper. You know that with statistics, STTN121 and other stats modules, most of the question papers, when you download them on the Ifundi site and so on, you download it with the memorandum. So yeah, it's question paper and then also memo. But remember on the previous video that I uploaded, which was part one, I've mentioned that you can have the memo and also the question paper, but you don't understand how they got those answers. So yeah, I'm gonna explain how they got those answers, how to get those probabilities, the chi-square, the t-table, the binomial distributions under the Bernoulli population, and so on. Now let's see. Okay, now this one, I think I've explained this one, which is option number one. Number two, when they say that the area under the probability density curve between A and B, I'm gonna show you how to find this probability. I think you did this when you guys were doing STTN121, under the probability, the continuous probability. I think you did that. And also, they say that the probability density function is greater or equal to 0 for all the values of x, meaning you cannot get the negative probability. It has to be greater or equal to 0, 0.35, 0.3 something, 0.1 something, 0.3, 0.7, and so on. So on this one, these are the properties, because they can tell you to write the properties of the probability density function under the continuous random variables. These are the properties. Okay, let's see. Okay, okay, this is how you see that the distribution is symmetric. I'm also going to explain this one when we do the questions. Okay, I think I talked on the previous video, I talked about the expected value, the variance, and also the population standard deviation. Okay, so this is the end of this one. We're going to go and check 8.11. Okay, then 8.11. Now we are under the normal probability distribution. Okay, normal probability distribution. Let me change this one to this color. Normal probability distribution. Okay, let's check. All right. Okay, guys. Another thing under the normal probability distribution, guys. Please note that if they give you a statement or they give you a question, and then on that question they say z, that they give you a symbol like this one. They give you something, they give you a statement, and also they give you something like this. I saw it there on STTN 121, and also I think STTF one, is it 121? Sure, if it's 121. There. If they give you a statement and also they give you a symbol like this one, just know that they're trying to tell you that Z, it's normally distributed. It's normally distributed with a mean of 0 and also a population standard deviation of 1 here. You see, this 0 is for population mean and also the population standard deviation of 1. This is how you see. Okay, I'm going to show you when you do that. Okay, they say now when the probability is less or equal to A, it means that the area under the curve, it's gonna, like, they're gonna shift it to left. Okay, but you'll see even this one. Don't worry, you'll see when we do. I think you did this when you were doing STTN 111, but it's fine. I'm gonna show you how to do this. And I remember I uploaded this other video. I said that if you are dealing with greater than or you are dealing with at least, remember greater than, this is the symbol of greater than here. This is the symbol of greater than. If you're dealing with greater than or you are dealing with this symbol here of at least, this one here, you are dealing with this. Just know that this symbol, we use it for it's at least. You want to use 1 minus the probability of Z. You will see when we do the questions. I will check here if we have the questions. I'm going to show you something here. Okay, let's see. Okay, this is the question. We have 4 questions now. I'm going to show you how to do this. Okay, they say that calculate the following probabilities where the Z is normally distributed with a mean, population mean, and also a population standard deviation of 1. So the population mean is 0, the population standard deviation is 1. Already, there's no need for us now to calculate the Z values because already we are given the Z values. There's no need for us to do that. Let's see. The first one, they say that calculate the probability where Z is less or equal to 1. Guys, remember, 1 is the same as 1, comma 0, 0. So on our table, we know that we're going to use a positive table. But remember, under the language of probability, we say that if you are dealing with, I will repeat, if you are dealing with greater than, you are dealing with greater or equal to, which is at least, you are dealing with more than, those are the terms that they normally use. If you are dealing with more than, okay, let me write it here. Okay, let me just do it like this. I just want to show you guys something. Okay, I'm gonna use the red one thing here. Okay, guys, if you are dealing with the greater than, I don't know if you guys will be able to see this, greater than, and also you are dealing with more than this, you are dealing with at least, greater than, more than, at least, and also, yeah, this one. If you're dealing with this three, this is when you are going to use 1 minus the probability. 1 minus the probability. So when I was doing probability, so I'm going to show you this one. But if you are dealing with, just going to try to do it like this, but I can try to change the color here and put this one, the one that I think you guys should be able to see, black, no black. And this one, no, this one, yeah. This one I think is fine. Okay. So if you are dealing with this here, if you're dealing with greater than, more than, at least you use 1 minus the probability. But now if you are dealing with less than, if they give you a question, you are dealing with less than, you are dealing with at most, because those are the terminologies or the terms that you normally use. And you're dealing with which one? Yeah, less than, at most. Yeah, you don't use probability, you don't use 1 minus the probability. This is the method that I normally use. I know that there are a lot of methods that you guys normally use, but if you prefer using my methods, yeah, when I was doing the statistics modules, I used to use this method. Don't use 1 minus probability, because I know that on the slides it's a they used a different methods. But I'm not saying that you guys should not use that method. It depends on you guys. Remember, you use the method that you think is going to work for you. So this is the one that I normally use. If they say, if you're dealing with less than, at most, and so on, you don't use 1 minus. I'm going to show you something. Okay, let's check. The probability where z is less or equal to, this symbol is for at most. So at most, positive 1. So we're going to go in here and check. You see here, it's 1 here. Remember I said 1 is the same as 1,0,0. You're going to check 1,0. The last digit, guys, remember, if we have 1, we know that 1 is the same as 1,000, because if you punch this number on the calculator, on your casual calculator, you say 1,0, you press equal sign, you will get the answer as 1. You know that you'll get the answer as 1. So it means that here on this one, we're going to check here. We'll be like, okay, now, since we have a positive z value, which is 1,0, what is my last digit in this case? It's 0 here. It's 0. And then you're going to say 0 divided by 100. It's still 0. And 0 is the same as 0,00. That's the reason why they used 0, under 0,00 here. Then you are left with 1,0. That's the reason why you go here under the z value of 1,0 and you go here, which is 00, under 0,00, which will give you 0,8413 for this. That's the reason why they didn't use 1 minus. I remember I said that if you are dealing with at most, this symbol is for at most, you don't use 1 minus. But if you're dealing with something like greater than, like this one, we are going to use 1 minus the probability. So yeah, now this one, okay, I know how they got that answer. Now for 2, we say, okay, now since they said the probability which is greater than 0,43, we're going to check 0,43. We're going to check what is your last digit in this case. Last digit, we'll be like, okay, the z is equal to 0,43 in this case. You need to ask yourself, in this case, what is the last digit? It's 3 here. Remember what I said, you divide 3 by 100, you will get 0,03, which means you're going to check it here under 0,03. Now you're left with 0,4. So it's going to be 0,4 here under 0,03. And then you will get 0,664. 664. Is it 6? I think it's 8, but let's check something. Okay, 664. Yeah, it's 664. You will get 0,664 because I can see those. Yeah, now I can see this. 0,664. But remember what I said. This is greater than. Remember what I said about greater than here. What you do? 1 minus the probability. So it's gonna be 1 minus here. 1 minus 0, 3.64. And then you get the answer for this one. That's the reason why they used this method, and then they got 0.33336. So that's how you do it. Because it was greater than. Remember what I said about greater than? 1 minus the probability. So with this one, yeah. This one, yeah. We just do this. Okay, with this one. Now, 3, they said the probability where z is less than negative 2,11. Remember, when we're dealing with less than, what do? You don't use 1 minus. You just go straight to the table, you check. But don't forget, what is the last digit? It's 1. Because it's, we're gonna write it here. We're gonna check under the negative table. So we're going to check. The last digit here is 1. You divide it by 100. You're gonna check under 0,01 here. And then you're gonna go and check negative 2,1 under 0,01. And then you'll get 0,0174. You see, 0,0174. So that's how you get the probability. So in this one, on this one, you don't use 1 minus. You know why? Remember, if here it's less than, what you do, you don't use 1 minus here. That's the reason. Now this one is between. It's between negative 2,54 and 1,83. So what you do if it's between, guys, remember, you don't, the method that I know, or the method that I used to use, that I think when I was doing statistics modules, I used to use this method. This is what you do if you're dealing with two numbers, the z values. If you're dealing with this one and this one, this is what you do. You find the probability for this number here, for this one, which is negative 2,54. The last digit will be what? And on this one will be 4. You divide it by 100. It's gonna be 0,04. Now you're left with what? Negative 2,5. So when you check the probability for the negative 1, you're going to check negative 2,5 here. Where is it? Where's the question? Negative 2,5 under 0,04. So negative 2,5 under 0,04, which is this one here. Negative 2,5. And you will get, you're going to go this side. You will get 0,0055. It means for this one, the probability will be 0,0055. You do the same with 1,83. The last digit is what? It's 3. You divide it by 100, you're going to get 0,03. And then you go here, 0,03, and then you want to check 1,8. Where's 1,8? 1, okay. Let's go and check it here. Where there's 1,8, because this one is end with 1,3. We see, where is it? That's the reason why I said this one 0,0055. It's for this one here, for negative 2,54. But for 1,83, you're going to check. Remember I said the last digit is what? It's 3. You divide it by 100, it's 0,03. So 0,03, it's here. And then you check 1,8, you go here, which will give you 0,9664. Now you have two values. You're going to check. If you have two values, you'll be like, okay, between 0,0055 and 0,9664, which one is the bigger number? It's like now you are finding what you call a range. Let me just put it as a range, because it's going to be the maximum number minus the minimum number, or subtract with the minimum, the large number, or the large number minus the smallest, something like that. The maximum minus the minimum. You want to check out between 0,9664 and 0,0055. Which one is the bigger number? Which is it's going to be 0,9664. Then you say 0,9664 minus 0,0055, and then you will get 0,9609. That's the reason why they got this. You see, you don't use 1 minus with this one. So yeah. Okay. I think you guys can do this. Since I've showed you, you can do this, and I believe that you will get the questions right. And then what's the other one? The normal distribution. On this one, remember the population mean on this one. Population mean is equal to 7. But check, what is that one? Or this one here? What is that one? The 149? Is it a population standard deviation, or what is it? Since we are dealing with the normal distribution, this one, you remember, guys, if they give you a population mean of 7 and this one, you're going to divide this one by 2. This one is the variance. This one is the variance. So we're going to do a square root of this one of 9, and you will get, I think you'll get something like 3. This one to show you something. Where is it? We see this one. It was 4. Population mean is 3, and then the variance is 4. Let me show you something. Where is it? You see the reason why they divide by 2, is because um it's because here on this one, because now it's a different, let me check if it's not, it's a different, yeah, it's still the same thing, yeah. The reason why, because population mean in this case is equal to what? Let's do it together. Population mean is equal to 3. And then the variance is equal to 4. But for us to get the standard deviation, you're going to do what? You're going to say the standard deviation, there is this simple, which is equal to what? Which is equal to a square root of 4. So we're going to do a square root of 4 in this case. We're going to do a square root of 4, which will give you 2. We're going to do a square root of 4, which will give you 2. And then this one is 3, because already we're given. And then I'm going to put this one here. Then I can just say population SD is equal to 2. Okay, let's go back. I want to show you guys something. You see this one? This is the one. This one is for the normal distribution. The normal distribution, where they say that X is normal distributed with a population mean and also the variance here. How do you get that? How do you move from variance to standard deviation? You do a square root for you to get the standard deviation. So now this is the formula that we are going to use. I think you guys used this formula when you guys were doing STTN121, that X is distributed as normal distributed with population mean and also the variance. Okay, let's go and check. So now we have the mean as 3, we have the standard deviation as 2. To get the z value here, because they said we must calculate the probability where X is less or equal to 5. Remember, if it's less or equal to 5, we don't use 1 minus. So we're going to say now the z is equal to what? Let me try to reduce this. Z is equal to, it says X minus the population mean. Okay, X minus the population mean, the formula. This is the formula. It says that X minus the population mean divided by population standard deviation. So here in this case, what is X? We're given it's 5 minus the population mean 3. Divide the whole thing by what? By 2. And then you get the z value. That's the reason why they did this. It says 5 minus 3 divided by 2. They got what? 1. Now remember, check. If now they got 1, you go to the table, you take the answer, you will get 0.8413, because you're not going to use 1 minus. So same applies to this one. But this one, remember, because it's greater than, you're going to use 1 minus the probability. That's the reason why they got the probability as 0.4013. And then after they said 1 minus the probability, because it's greater than, remember. It's greater than. If it's less or equal to or less than, we don't use 1 minus. So yeah. And then what is the other one? Okay, so then I think other questions you guys can do them, since I have explained the basics. Okay, and then this how you do. Even this one you are given. This one, when you look at this one, already you are given the mean is 200. You are given the standard deviation as 5. So they tell you to find the probabilities. They said more than. You're going to use 1 minus the probability. Then if it's between this number and this one, you don't use 1 minus. You just find the probability for the first one and the probability for the second one. You compare them. You'll be like, the minimum, I mean, you compare between those two probabilities. You'd be like, okay, between those two probabilities, which one is the bigger one? You say the bigger one, you subtract it with the smaller one, and then yeah, that's how you do it. And then what's the other one? Okay, I think most students, they have problem with this. Look at this one. I just want to show you guys something. When we look at the scenario, they say the normal distribution of the number of the calories in a salad on the menu, it has a mean of what? Of 200. Okay. And a standard deviation SD as 5. Okay. Now, the value of B is such that now they tell you find the probability that the salad you choose, the value of B is such that the probability, you get this, guys, the probability of X where it's less, or I'm going to put the less or equal to B, which is equal to 0.87. Let me put the symbol less or equal to. Okay, less or equal to. Now look at this one. Interesting question. Now look at this. The question is, we know the formula. It says that Z is equal to what? Is this equal to population mean minus x minus population mean, then divide by what? I'm gonna put the division, divide by the population standard deviation. Okay, let me just do it like this. The population standard deviation, like this. But then now, when you check here, the population standard deviation, like this. Now, look at this. Here's the question. You need to remember, guys, with statistics, you don't, especially with this module, you don't, because it's not a multiple choice like STTN121, where you'll be like, no, I think the answer is B, I think the answer is C, or maybe I'll just um be like, I'm gonna guess the answer is D. No, you don't do that. If you want to make sure that you pass this module and make sure that you understand, the aim is to make sure that you guys understand the basics. So this is what you do. You check on this question. It says they want me, you need to check. They say that already you are given the population mean as 200. You're given the standard deviation as 5. And also, when you check this, they say that the probability where x is less or equal to b, it means that I'm not going to use 1 minus. Okay, because it's less or equal to, and less or equal to it's at most. But then now check this. Check this. They say now, when you look at this, already you are given the probability of 0.87. And you remember, Guti, when you are given a probability of 0.87, this is what you do. You remember, if they give you a statement and they want you to calculate the probability, what are you going to use for you to get the probability? You need to ask yourself that during the test or in the exam. What are you going to use to get the probability? Obviously, you're going to use the z-value to get the probability. Now, here, because now the examiners, the lecturers will be like, okay, since you guys understand how they got the how you know how to calculate the z-value. After calculating the z-value, you find the probability using the z-value. Now let's give you the probability, and we want you to use that probability to get the z-value. How are we going to do that? You're going to use the probability of 0.87. It means that when you check on the probability values at the table, when you check there, you will see that you're gonna get a value like 0.87000. You see, because it's gonna be 4 digits. 0.8700, something like that. You're going to check where it corresponds with the z-value. The aim is for you to get a z-value for you using the probability that you are given. Let's go and check. Let's go and check. I'm gonna show you how they got the thing. The what is the thing? I'm gonna show you something. I need there's something that I need. Let's go back to the table. I'll show you how they got the answer. It's which option? Hmm, which option? Which option? Um 28, option 4. Just wanna show you guys something. You see, they didn't do that option 4. Oh, here it is. Okay, let me show you guys something then. How you gonna get 0, you're gonna go here with the table. You're going to check if the probability is 0.8 something. Do you think you're gonna get it under the negative table? Because when you check under the negative table, it's 0.00 something, 0.00. It means you're gonna get it under the positive table, which you're going to check here. I'm just gonna try to zoom this so that okay, you're going to check it here. Where can we get 0.8? This is 0.84, 0.88. We have 0.87 here, 0.87, and we know here it's under 0.03 because 0.0, 0.00, 0.01, 0.02. This is 0.03. So 0.8708, 0.8720, 0.8740, 0.8770, 0.879 something, 0.8810. It means that you're going to take this value, which is 0.8708. That's the one, 0.870, which is fall under 1.1, under 0.03. So the z value, what is the z value? 1.13. So that's the reason why they got answer there of this of the z value as 1.13. Where is it? Where is it? Where is it? Where is it? At 1.13. Now you use the formula. Remember on the formula I said x minus the population mean divided by the standard deviation. Population mean it was 200. The standard deviation was 5. But the question is, do you have the value of x? You don't. That's the reason why they give you the probability value. For you to use that probability value to get what? To get the z value. Once you get the z value, then you will be able to get the probability. I mean, the value of b. Now, it's going to be, when you see x, you're going to replace x with the b. b minus 200 divided by 5. Now, it's going to be what? 1.13 multiplied by, because you do cross multiply, 1.13 multiplied by 5. And then this one is going to be b minus, let's do it here. You're going to have something like b minus 200. 200, which is equal to, when you say 1.13, when you check it here on the calculator, when you say 1.13, 1.13 multiplied by 5, you will get 5.65. You will get 5.65. Now, to get the value of b, you're going to take that 200 minus 200 to this side, and it's going to be positive. So it's going to be like what? It's going to be 200 plus 200, because when you take this to this side, I agree it's negative now. When you take this to this side, it's going to be positive. It's going to be 200 plus 5.65. And you will get the value of b as what? I think we're going to 200. When we check here, you're going to get 200 plus 5.65. You will get the answer is 205.65. That's the reason why they got the value of b as 205.65. That's the reason why they got this value. So I hope you guys understand. Yeah, I think you guys, when you do the exercises, you can also do this one to practice. So yeah, that was 8.11. That was 8.11, which is going to be under part 2. Okay, and then now under 8.12, now we're under the sampling distributions and also the central limit theorem. Interesting one. And I think you guys, you did this central limit theorem on STTN121, the sampling distribution, and also the central limit theorem when you guys are doing STTN111. Let's see. Now here, you need to, everything you do under this module of statistics, make sure that you understand the definitions. Imagine if they give you a question, they tell you to calculate the central limit theorem. You don't even know the definition of the central limit theorem. And they give you a question, they say calculate under the sampling distribution. You don't even know what is the sampling distribution. So it's very important, guys, to understand the definitions of whatever that you guys are doing, especially with the module. That's the only way you will be able to understand the module. So this is what you do. The definition under the sampling distribution, the probability distribution of a statistics is the definition of that sampling distribution, meaning the sampling distribution is the probability distribution of a statistics. The sampling distribution of the mean is the probability distribution of x bar, which is called the sampling distribution of that mean here. You see, it's not difficult. Yeah. And then what is the other one? Okay, now this is what you do. The mean, the EX, is equal to the population mean. Here, you know the population mean, I've been talking about it. The var x bar, which is the variance, is equal to the variance divided by n, okay, which is equal to this one. All right. Now, look at this. The standard deviation is equal to the standard deviation over square root of n. This is what, this one here. They can give you a statement and then they tell you to calculate the standard error of the mean. This is the formula that we use. Standard deviation over square root of n to get the standard error of the mean. See when we do the questions. So to show you guys the formulas. And then this is the definition of a central limit theorem. This is very important. The central limit theorem, guys, it's very important, this one. You remember under the sampling, it was the continuous, the probability distribution. We said z is equal to x minus the population mean divided by population standard deviation. But then now check, under the central limit theorem, the only thing that they are going to add is n, square root of n. And remember I said this whole part here, it's what we call the standard error of the mean. If they give you a question and they want you to calculate the standard error of the mean, this is the formula that you are going to use, this one. You just say the standard deviation over square root of n, then you get the standard error of the mean. So here in this case, they say that whatever the population or the distribution of X bar, which is the sample mean, is approximately normal when N is large in what you call a random sampling from the population with the mean and also a standard deviation. Now now they attempt to tell you something that when N is large, it means that the distribution of X bar is approximately normal with a mean and also a standard deviation, which is the one for the standard error of the mean. And it's approximately normal with the mean of 0 and also the standard deviation of 1. But this is what you do. This is the formula. X bar, which is the sample mean. X bar standing for the sample mean. Nu, this one, is standing for population mean. Then this one, population standard deviation. And then N is the random sampling or the random sample. Let's go and see. This is the formula. Let's check if we are given the questions. Okay, now it says that suppose it is known that the population distribution of a gripping power of industrial workers has an average of 110. Remember, guys, if you're given a statement like this one, you use a pencil, try to find the keywords and the important words that will help you to calculate that probability. So the average is 110 and a standard deviation of 10. I remember, I think it was it last semester? There were students struggling to understand the difference between the central limit theorem and the normal distributions. The one for Z is equal to X minus mu, the population mean, and then divide by population standard deviation. And the other one for Z is equal to X bar minus the population mean, divided by population standard deviation over square root of N for the central limit theorem. So I want to be like, okay, so how do you see that these two formulas, which one to use? Like when you're giving a statement, how do you see that now I'm going to use the first one without N and the second one with square root of N or the N? How do you see? Guys, they give you a statement, and then they tell that it's normal distributed. The minute they introduce the value of N, the random sample, that's when you're going to use the central limit theorem formula, the one with N, square root of N. Look at this. We're given the average of 110. We're given the standard deviation of 10 units. Now, they say for a random sample, which is N, random sample of 75. Now, let's check. We write down our information to do this. We say population, okay, we say the sample mean, which is the average. Remember, the sample mean is the average. Sample mean is equal to 110. Okay. SD, I'm just going to write SD standard deviation is equal to 10. What about N is equal to 75? So it's going to be easy for me to calculate that the probability that they want. Now they say that determine the probability that the sample average creeping power will be between 109 and 112. So it means that here in this case, here, it's going to be a population mean because I made a mistake here. The population mean will be 1110. Population mean. Because you see the sample average, which is the sample mean, which is now it's 109 and 1112. So this is what you do. We remember when we are dealing with between, what you do, you don't use 1 minus. That's the method that I use. Because even maybe on the slides it's different, but you'll end up getting the same answer. We're going to start. We say now the first one, Z, we know the formula of the central limit theorem. The X bar, which is 109 minus 112. No, 109 minus the population mean, which is 110 divided by the standard deviation 10. And also let me just put it like this and do something like this so that you can all see what I'm going to do. And then it's gonna be 10. Okay, 10. And then square root of what? Square root of 75. 75. I think you guys will be able to see this. 75. Yeah, something like this. 75. Therefore, here it's gonna be what? Now it's gonna be the Z is equal to, when you check that on the calculator, we say 109 minus 110, and then with 10 square root of 75. You will get minus 0.866. Don't forget to round off your final answer to two decimal place. So minus 0.866, which will be minus 0.87 here. We go and find the probability for this one, minus 0.87. This was the formula sheet. I remember I've opened the formula sheet. I think it was here. Here, this one. Check. There was a formula sheet that, okay, this is the one. Try to zoom here so that we want to check under the negative table, minus 0.87. It was 87. So we want to check minus 0.8 here, and then we check 7, because the last digit is 7 here. Here it is. Okay, here it is. I'm gonna put this and go down here, so that, because it's down there, here, minus 0.87. This side, this side, this side, this side, which is 0.1922. 0.1922. The probability, 0.1922. But I write it here. And then the p-value, the probability is equal to 0.1922. We are done with 109. The p-value, let me just put the p-value 1922. Now we are done with 109. We go to the 14112. So now the z is equal to 112 minus the population mean, which is 110. And then because you're going to divide by what? We're going to do something like this. We say divide by what? What is the standard deviation? Already we are given, which is 10 under square root of 75. So I remember it's 7 square root. Yeah, under the square root of 75. Then when I get it like this, square root of 75. I'm gonna put the square root there. Okay. Okay, I'm gonna put something like this. Square root of 75. Okay, this one. So now when you check square root of 75, now we're gonna do it like this. We're gonna put, we punch that on the calculator. It's 112 minus 110 divided by 10 was square root of 75, which is 1.73. This one, when you round it off to decimal place, it's going to get to, you get z as 1.73. Now the p-value, for this one, is equal to, we're going to check the probability there on the formula sheet under the positive table. We're going to check 1.7 under 0.03, because the last digit, it's 0.03. It's 3. We divide it by 100, we're going to get 0.03. We're going to check 1.7 here. Where's 0.03? It's here, here, and then this is 0.9582. 0.9582, and then 0.9582. Now we have two probabilities. What you do, you compare them. We say, okay, between, just do this, between, okay, between which value? Between 0.9582 and 0.1922, which one are we going to take? The bigger one, it's 0.9582 minus 0.1922, and then you get the answer. So it's gonna be 0.9582 minus 0.1922. You will get 0.766. The answer for this one, 0.766. And I believe that you guys can do the second one. The one with greater than. We know that the one with greater than, you're going to use 1 minus the probability after getting the probability on the table. We'll see. Yeah, I think I gave you the answer for this one. 0, on my calculator, 0.766. Can also write it down here. Equal to 0.766. Yeah, 0.766. Change this to right here. This 0.766. Okay, so yeah, I think that was the end of 8.12. Now we move to 8.13. So now We did the continuous random variable, the normal probability distribution, the sampling distributions, and also the central limit theorem. Now we're going to do the student's T, followed by the chi-square and the F distribution. Okay, the student T probability distribution. Okay, they say now, the population mean and the population standard deviation was known. Okay, let's go back here and check. Okay. Okay, let's look at, just do this. Okay, this is the formula for the student T. T is equal to X bar as the sample mean minus the population mean divided by the sample standard deviation over square root of. Look at this. We see the formula of the student T is, it's when you compare this formula with the one for the central limit theorem, that's when you will see that no man, the only difference is that the other one you are given the population standard deviation. You were given something like the other one is something like this with a square root of n here, with a square root of n. But this one, it's as the sample standard deviation. How do you see that with this one? You How do you see that you're going to use this formula for the student T when you're given a question? Interesting question. One, they will give you a data set. On the data set, you're going to find the mean. I think last semester I showed you guys how to calculate the mean and standard deviation in the calculator. Substitute you punch the calculator, follow the methods. The mean, I find the standard deviation, find what you call the degrees of freedom, which is n minus 1 here. But firstly, you find the test statistic, which is T here. Let's go. Okay. This is very important, guys. Ne? Let me do this. This is very important. Ne? Okay. They say the T distribution is a probability distribution that is used to estimate the population parameter when the sample size is small. Guys, please be careful of this. Please be careful of this. Look at this. It means that you use the T distribution formula when n is less than 30. If they give you the statement or the information, and when you check there, you see that n is less than 30. But not only n is less than 30, n is less than 30, and also, just do this, n is less than 30, and also the population standard deviation is unknown. How do you say that the population standard deviation is unknown? It means that you will be given the sample standard deviation. Guys, this is very important. N is less than 30, and the population standard deviation is unknown. That is when you are going to use the student T distribution. You say T is equal to X bar minus the population mean divided by the standard deviation over square root of n. That is when now I think now you guys understand the reason why you use the student T. Why are you using student T distribution formula? One, n must be less than 30. You must get a value of less than 30. Now, someone, I think, don't remember this when I think I was at the tutor SI for STTN121. Yeah. Someone asked me a question, or okay, what if n is greater than 30? No, what if n is less than 30 and the population standard deviation is known? What if n is less than 30 and population standard deviation is known? If it's like that, you're not going to use the formula of the student T distribution. We'll only use student T distribution only if and only if the n is less than 30 and we are dealing with the sample standard deviation. Let's go and check, show you. And don't forget the one for the degrees of freedom, which is n minus 1. Okay, let me show you. Don't forget the formula. Okay, I'm going to show you guys something. And the degrees of freedom will help us to find. I'm going to show you. Okay, this is what they do, the student T. They're going to give you something like this. They will say the probability where the t is less or equal to a value here. Okay, let's see if we have a question. Okay, for the student t, this is the formula. I think it's there on the formula sheet. Let me check if it's there. I think it's there. I'm going to explain how to use that formula. This is the one. I think this is the one. Yeah, this is the one. This is the formula that you're going to use. It's there on the formula sheet because you'll be given a formula sheet. So on this one, let's look at the question. I want to show you guys something. So for you to expand this whole thing here, you can also do it like this. I mean, I will advise you guys to use this one, maybe to get the P, but I'm going to explain it. For example, they can give you this. I'm not sure if it's 2 or 3 marks. I'm not sure about the mark allocation for this one. They can give you this one, then they tell you to calculate the probability. They say now calculate the following probability. T is greater than. That's 20. 20. Remember, they can give you a statement. And when I need to check if n is less than 30 and you're dealing with the sample standard deviation, you get the T. Once you get the T, step one, once you get the T, also don't forget that once you get the T, you need you need the degrees of freedom, n minus 1. Why do you need the degrees of freedom? It will help you to get the accurate answer of the value of the probability. It will help you to get the probability. So it means that with the student t distribution, once you get that value, 1,8 something, 3, something, for you to get the probability, you're going to get it there on the table. This is the table that you will get the value you are varying, because you will be given this, the student t, you will be given something like this. The degrees of freedom, the one, if n, let's say for n is equal to 12, you're going to say 12 minus 1, which will be 11, and you're going to check it there. Obviously, this table is not, there's this other one, you're going to check it there. Okay, but let's check here on this one. I want to show you guys something. Is it? Okay, here, they say that the probability where t is greater than, guys, don't forget, if t is greater than, if z is greater than, what do you do? If it's greater than 1 minus, don't forget that, 1 minus the probability. But now, because we are dealing with the student t, you want to say 1 minus t less or equal to, less than 1,875. You are given a hint of you are given the degrees of freedom as 1,875. Okay, okay, guys. Okay, sorry about that. Okay, now let's check. We are given the degrees of freedom as 24. So it means that they're trying to tell you that use the degrees of freedom as 24. Remember, don't forget, if it's greater than 1 minus the probability. Okay, then this is what you do. 1 minus the probability where t is less than 1,875. Now, this is the table. Let me try to zoom the table so that you can all see. This is the table. We want to check. We are going to check the degrees of freedom is 24. Where's 24? 24 is here. And when you check under this, because I think we have 2 or 3 tables. When we check under this table, do we have 1,875? Do we have that value under 24? 1,875. Do we have it? Let's check. No, we don't. We don't have that value. And what do you do? Let's check. We're going to go and check to another table again. Because I think it's, how many tables? I think it's 2 or 3. We're going to check under these tables. Because the first one, we didn't find 1,875. It's not even here. And you don't have any values close to 1,875. Remember, guys, if you don't find that value, 1,875 there on the first table, move to another one here. We're going to check here. Still, the degrees of freedom, 24, because we were given. If they don't give you, they will give you n. You say degrees of freedom is equal to n minus 1. It was 24 here. you're going to check. Now, if you check, I want to show you guys something. Ne? If you check here 24, do we have 1,3, 1,3, 1,4, 1,5, 1,6, 1,6? Even this one, you're not going to use it. You know why? You know why? Ne? The t value, it's 1,875. If we check under the degrees of freedom of 40, of 24 there, when you check, it's 1,4, 1,3, 1,3. Do we have a value that's between where you're going to find 1,875 there? We don't, because under 24 here, when you go there, the value they end with 1,66. It's out. It's not even there. You're not going to use this one. This one is out. You're going to check. This is how you calculate the t value, guys. It's very simple and interesting. Firstly, if you are given already the t, you check if it's greater than. If it's greater than, you say 1 minus the t. 2, you check if you are given the degrees of freedom. Here, when we check here, you'll be like, okay, where's 24? This is 24. Here, 24 is there. But remember, the t value is 1,875. Guys, please be careful of this. If it happens that we have 1,87, exactly that 1,875 number here. Let's say it was 1,828. Exactly. When you check it there, it's there. You just go up here. You take this answer. You say, if the probabilities were greater than, you say 1 minus 0,960. Get the answer, you're done. Okay? If it's less than, you just get this answer, you're done. Only if that value, exactly that value is there, you're going to take it. But now check here. We don't have 1,875 value. What do you do? You're going to check the range, the two values. Inside those two values, there must be 1,875. But check, if it's 1,875, between 1,828 and 1,896, there is 1,875 there. Then what you do? It means that it's there, 1,875 it's between 1,828 and 1,896. Now, it means that we have this one here and this one here, two values. Now, 0,960 and 0,965. The other one we'll call it P1, the other one we'll call it P2. Okay, let's check. This is what we do. Now, check this. I'm just going to try to do it like this. You see now, what will be the value of P1? P1 is 0,960. The first one, guys, it's the one for P1. We're not just going to do it like this. The first one, guys, is P1. Then the second one here, it's P2. It's the first one, the second one is P2. So already I've showed you guys the formula for you to use to get the probability. P1, P2. Now, what about the T? The T1 and T2. T1, T2. T1 will be 1,828. The first one here, guys, will be T1. Obviously, you can't have P1 here and then you come in, you get T2 there. No. This one will be T1. This one will be T1. Will be T1. And then this one, the second one, 1,896. Well, 1,896 will be T2. T2 here. You see, that's the reason I'm saying this is interesting. T2, 1,896. So since now you know how they got one P1, P2, T2, T1. What about TG? TG, guys, is the same. They say that the TG, it's 1,875. You know the reason why they say it's 1,875. Let's go and check. Okay, T1 is 1,828, T2 1,896. We know how they got P1, P2, T1, T2. They say that the TG this is the TG, guys. 1,875 is the TG. So where you see the TG, you want to put this value of the test statistic. Then you substitute this. This is the formula, ne? You substitute this here. Because now I've showed you how they got P1 here, but P2 here. I will repeat again. The T value, it was 1,875. And we have three tables. The first table, we try to check if 1,875 is there. This one is not even there. It's not even there, 1,875. Now, well, the second one, under the degrees of freedom of 24, is not even there. Because we need the range. Now, the third table, when we check between 1,828 and 1,896, 1,875 is there. then that's when you'll be like, oh, the first one is P1, the second one is P2. This one is T1, this one is T2. Now you use the formula, but the TG will be the value of the T that you are given. You substitute, and then don't forget it was greater than 1 minus 0.9635 of this. Then you get 0.0365. Okay, that will be the probability. That will be the probability. Even this one, you see, they've given you the T as 2.201. Then they give you N. How do you get the degrees of freedom? N minus 1, 6 minus 1, which is 5, the degrees of freedom. You know that when you check, again now it's 2.2. When you check on the table, the first one, do you have, which is where it was 5. We're going to go to 5, the degrees of freedom here at 5. Do you have the value of 2.201? Let's check here. Or the range. No, check. We don't. Because now it's 1.3, it's 0.132 and 267. You see, the first one is out. The second one, we check the 5 here. 1.6, 1.7, 1.8, 1.9. We don't, because 2 point something is not even there. This one, 5 here. When we check between, I guess 2.201. So we can't take 2.015 and 2.098 because it's 2.2. So obviously the range will be between 2.191 and 2.297. Inside those two values, there is 2.201. You see, there is 2.201. This one will be P1, this one will be P2. This one will be T1, this one will be T2. What will be the TG? The TG will be 2.201. This is the formula that you're going to use. It was greater than 1 minus. Use this formula to substitute, and then you will get 1 minus 0.9605, and then you will get 0.0395, and then you are done. That's how you deal with the T tables, with the T, to find the T. So I believe that you guys now you're good, sorted. Oh, we see this one. If T, it's T12 determine the value of K such that the probability of T is less than K 0.9. And then this one greater than, you find this one. This one is less than, so you're not gonna use 1 minus. Still the same thing. Even this one, you're gonna use that method I've showed you. But this one, they say that T12, and then such that already you are given the probability of 0.9. Let's check to show you guys something. You see, already, if the probability that you are given is 0.9, and then the degrees of, this is when they say T12, it's the degrees of freedom of 12. This is what you to get the value of K. Simple. You just go here. You say, okay, it's 12. And then already they've given you 0.9. I agree 0.9 is the same as 0.900. Then it means that the K will be 1.356. The K will be 1.356. That's the reason why they say that the K is 1.356. That one, yeah. What's the other one? Okay, so with this one here, with this one, it's 0.05. The degrees of freedom is 12. So how do you get that? Where is it? Where is it? So I can show something. But remember, you need to check if it's greater than. Yes, it's greater than. So you'll say 1 minus the answer that you'll get on the table, which is, it's gonna be 1 minus 0.05. You get 0.95. You go to the table, the degrees of freedom is 12. And you go and check 0.95. The values will always be there. They're the one that's the probability. 0.950 is the same as 0.95. And then they correspond with what? 1.782. Then there, you're going to get it there, 1.782. Only if they give you the probability value and they want you to find the unknown, which is K. That's how you do it. So you can now see that the student T distribution is easy. So yeah. So if you guys are struggling, you can ask the questions, send me a message and ask. So we are done with the student T. And then, yeah, even this one, I believe that you can do this one, even this one, interesting questions. And then, now we're on, I think, the chi-square. We're done with the student T, we're on the chi-square. Okay, guys, the chi-square distribution. So the chi-square distribution here on this one. Okay, let's look at how they calculate the chi-square. This is the symbol for the chi-square. X squared n distribution is the one for the chi-square. So for the chi-square, I'm going to show you guys the formula of the chi-square. Guys, do you remember I said this one is for the chi-square, and we also have a table for the chi-square. They said x is greater or equal to this thing that will give you a value of the chi-square. This one. Let's look at the question so that I can show you something. The one where you are given the chi-square. This is the table that you are going to use for the chi-square. Let's check on the formula sheet. I want to show you guys the formula for the chi-square. That one is the T table. We have this one is the T table. I want to show you guys the one for the chi-square. This is the F table. Is it? Let me check here. This one. Okay. The chi-square table. I think you'll be given that table. So, guys, if I want a question where you were given something like this. Okay, check now. On this one, they say determine x squared and 8 at 0,1. How do you get this? It's related to chi-square. Né? It means that the alpha is 0,1 here. Alpha is 0,1. Remember, I'm going to the formula. Alpha is equal to 0,1. And now the degrees of freedom is 8. So they're just referring to now go to the degrees of freedom of 8 and check the alpha of 0,1. Guys, remember, with regards to these tables, you will be given a table, the chi-square table for 0,1, the chi-square table for 0,05, and also the 0,10 or 10%, 10%, 5%, and 1%. So when you check here, you check 8, you check under 0,1 that were given there, which will give you the value of the chi-square as 13,4. The value of the k there, it was 13,4. You see, the chi-square is easy because they will give you the degrees of freedom, they will give you the value that, which is the alpha, this the alpha value. Then you just go to the table, then you get that value. So yeah. And this one here, they say determine the probability of less than 22.4. If x squared 13, what is this 13? 13 is the degrees of freedom. Let me show you something. Where is it? Degrees of freedom is 13. Now, the value that we're given was 22.4. So you want to say, because it's greater than 1 minus probability that x is greater than 22.4, because it's greater than. The question is, do you know this alpha? You don't know the alpha. So therefore, you're going to check under 13. What's the table? You're going to check 13 here. We're gonna check where there is exactly 22.4. Exactly that number, 22.4. Now look at this. You are given the degrees of freedom here. This is where you're gonna find the degrees of freedom. You are given 22.4. They want you to find this alpha, but you don't have alpha. How do you get the alpha? You're gonna use the degrees of the degrees of freedom as 13, and also you're going to use the value 22.4, where there's exactly 22.4. This is how you're gonna find it. You're going to check there, you'll be like, oh, it's 0,05, but don't forget it was greater than. So therefore, 1 minus 0,05, you will get 0,95. And then that's how you get the probability of the chi-square. So I believe you guys now understand. So the last one will be the F distribution table. Guys, the F distribution table, you'll be given, I think it's, let me show you something on the formula sheet. The F is gonna show there. You see the F table, the one for significance level of 0,05 and the other one for, where is it? I think they will also give you the other one for 0,01. But you need to check the alpha there. You need to check the alpha, the value of the alpha. So this is the formula that we use for the F table. Let's check. V1, V2, and the alpha. Now you need to check the significance of that you will be given. If it's 0,01, then go to the F table of 0,01 and check there. Let's check. Let's see. They've given us the determine the value of k such that the probability where k is greater than the probability where x is greater than k is equal to 0,05. Now, with 5 and 10 degrees of freedom, the 5 will be V1, guys. The 5 will be V1. And 10 will be V2. Now, when you go to when you check, already it's under 0,05. When you go and check under 0,05, the table of 0,05, what is the V1? I said it's 5 here. What is V2? I said it's 10. We'll be like, oh, this is where they correspond on 3.33. Now you see, then you get the value of k is 3.33. That's how you find. You see, you can see. Look at the chi-square and the F table. They just give you the values. You go to the table, you get the value that they want, the k or the probability value. That's how you deal with the F table. Now here, look at this one. We are given F, determine the F value under 0,01 table. It's 7 and 8. It means 7 will be V1, 8 will be V2. There's a equal to 6,18. V1 is 7, V2 is 8. Let's go. Where's V1? V1 is what? It's 7 here. V2 is what? It's 8 here. Where they correspond? Let's check. Or no, this one is for 0,05. So I'm not going to use this one. It's for 0,05 because they want us to use the one for 0,01. 0,01. I agree on this one. On this one here, we use the one for the table for 0,05. Okay. Okay, the table for 0,05. Okay, just 0,05. So let me check on the formula sheet if I can find. This one is for 0,05. And then looking for the one for 0,01. It's not even the table, but I believe they will give you the F distribution. Yeah, this is the one. Remember, guys, F distribution table, you have two tables. It's either 0,01, 0,05. How do you see that? You need to find the one for the 0,01 and 0,05. They will give you something like this. Something like this. This one is for 0,01. The previous one was for 0,05. They were given something like this. You see, 0,05. You want to go to the table. So V1 is 7, 8 is V2. So V1, this is 7 for V1, and V2 is 8. And then they correspond where? At 6,18. You are done. You see? Then you are done. So yeah, I believe that you guys now understand the F table, the chi-square, the student T table. You see, it's interesting. So yeah, I think that will be the end of part 2. Then part 3, I'll be tackling the questions on part 3. Questions on part 3. So yeah, thank you. Please don't forget to like and subscribe to my YouTube videos. So yeah, so that you can get more videos of STTN121, test 1 preparation, and also test 2, test 3, and also for the exam revision. So yeah, thank you guys.